All right, so finishing up the last part of this note, just a couple of examples for you. So an example, electric belt sander. So the typical one you'd use in a shop class. You're plugging it into the wall, so it's a 120 volt outlet. So for the majority of equipment that we use, we plug into 120 outlets. So if you look on the information tag for the tool, it tells you its amperage, or what the current it will draw. So what's the internal resistance if we have an 11 amp sander? So we know volts, and we know our current. So we are using V equals IR. So the resistance is kind of like the strength of the motor, how much resistance is inside that sander, or resistance is coming from making the motor work. So we are plugged into a 120 with 11 amps, so we're looking for resistance. So I'm going to divide both sides by 11, and what we find when we do that, we get 120 divided by 11 is 10.9 ohms. All right, so therefore 10.9 ohms of resistance. All right, now what happens if you upgrade and you use the heavy duty sander? So when you look at it, all this information's on the plate of the piece of equipment. You just never look at it. So the internal resistance, so if we go to a heavy duty sander, because if you look, we were at 10.9 ohms. Now this one has an internal resistance, or motor power, or I shouldn't say motor power, but the motor creates a resistance of 25 ohms. What happens? So the voltage, again, it's plugged into a 120. We are looking for the current, and the resistance is 25. So divide both sides by 25. And what happens then is you find that your current drops way down, or slows right down. So the current is 4.8 amps. So the other one had lower resistance, but the current was much, much higher. Here, because we have a higher resistance, the electrons have more chairs to hurdle. Think of that, so it slows them down. So now you have 4.8 amps that's flowing in the system. All right. So all that information, if you do use a power tool today, take a look to see if you can find the information plate there. Final formula here, I'm going to just show them to you here quickly, is power. So we've talked about electrical energy now. The other topic was power. So the formula is P equals IV, and we can have a couple of iterations. So I'm going to give you all three formulas. So P equals IV is your first formula. I'm going to do some math substitution. So for example, I'm going to replace V with IR. Okay, so power equals I, and I'm replacing, I use brackets to show that, V is equal to IR. Okay, and that comes from this formula here. You're not going to have to regurgitate this or do it for me again. I just want to show you where it comes from. So there's your second formula. So here's your first. Here's your second. They're all calculating power. I'll start fresh again. P equals IV. Now I'm going to rearrange this formula over here for a sec, and I'm going to get I by itself. So that would be V over R. So I just divided both sides by R. All right. So I'm going to replace that formula over here. So P equals V over R multiplied by V. So power equals V squared over R. All right. And there's our third formula. Okay. So to sum it up, power is IV, which is equal to I squared R, which is equal to V squared R. All right. Yes, I know, one equal sign per line. I always try to drum that into you, but it's a little bit different here because I'm showing you all the possible combinations for power. It just simplifies it on a cheat sheet or formula sheet for you. There's all the equations that will calculate power and combinations thereof. Okay. So when we flip around then for an example, what is the maximum power? So again, it's right there. We're looking for power. Power is the unknown. From a 120, so we're going to have to use the formula that has voltage, and we know the amp, or the breaker, is 15 amps. All right, so it is on a breaker, so we know we can't draw more than 15 amps. So what is the power? So flipping back, I've got V and I. So power is I times V, so it's the initial formula. P equals IV. So we will have 15 multiplied by 120. And what we get there, 15 times the 120 is 1800. And remember, power is in watts. So therefore, 1800 watts of power. All right. Similar example, all we're really doing is I'm just giving you getting opportunity to see the other formulas. So what's the power rating of a stereo amp? Okay, so this is your amp. If you plug it into a 120 wall, so again, into a 120 wall socket, the resistance R is 85 ohms. Again, if you look at the back plate of your amp, it has all this information for you. We want to know what power is. So what is the power of this particular amp? So we need a formula with V and R in it. So you look at your 3 iterations, V and R right there. So V squared over R is your power. So power equals V squared over R. 120 squared over your resistance of 85. Doing that calculation, divided by the 85, we get a 169.4 watts. So it's about 170 watt stereo amp. Okay? So therefore, 170 watt power amp. All right, and that's how the calculations are done. If you, like I said, if you look at the rear plates, or if you look at plates on power equipment, all that information is there in some form or another, so you can easily do the calculations to figure out one value or another. That's it. Any questions? So today you're just playing with all these little formulas, you're just practicing decoding, finding the correct formula, and we'll extend it from there. All right, good luck.